For nearly 2 centuries, Holland has been the epitome of fine British gunmaking. Known globally for its attention to detail, precision, and artistry, the company has perfected the craft of creating some of the finest sporting shotguns and rifles. Every Holland firearm represents the culmination of centuries of tradition, innovation, and superior craftsmanship. The making of these masterpieces involves numerous stages, each playing a vital role in shaping the final product. The barrel of a gun is often considered its heart, directly influencing the firearm's accuracy, balance, and performance. At Holland, the production of the barrel begins with the selection of the highest grade steel, which is carefully inspected for any imperfections that could affect its integrity or performance. The barrels are then drilled with precision to create the bore, the internal passage through which the bullet or shot travels. For shotguns, the interior of the barrel is smooth to allow for the spread of shot, while rifle barrels are rifled, meaning they have helical grooves cut into them. These grooves impart a spin to the bullet, stabilizing it during flight for increased accuracy. Once the barrels are shaped and rifled, they are subject to rigorous quality checks. Each barrel undergoes tests to confirm it meets the company's stringent standards. Any deviation from these standards could lead to imperfections in accuracy or performance, which is unacceptable in a Holland firearm. The final touch is the fitting of the barrel to the action and the stock, ensuring that the balance is perfect and that the gun handles with the ease and precision that Holland is known for. The stock of a firearm, often made from premium walnut, serves as both the structural backbone and the aesthetic heart of the gun. The wood used is carefully selected for its strength, beauty, and ability to absorb the recoil of firing. Walnut is favored for its unique grain patterns, resilience, and durability, which make it ideal for crafting custom, handmade stocks. At Holland, the creation of a stock is a marriage of art and function. The process begins with the careful selection of the wood, followed by shaping the blank into a rough stock that will eventually be custom-fitted to the user. The stock must not only fit the action and barrel perfectly, but also suit the individual shooter's measurements. This personalized fit ensures that the firearm is not only comfortable to use, but also maximizes accuracy by aligning the shooter's body with the sights and the barrel. The stock is hand-carved and sanded to achieve its final shape. Every curve, every inch of the stock is crafted with precision, ensuring it provides a seamless extension of the shooter's body. The fine wood grain is enhanced through multiple layers of hand-rubbed oil, which not only protects the wood, but also brings out its natural beauty. The result is a stock that is as beautiful as it is functional, making it a defining feature of every Holland gun. The action of a gun is its mechanical core, the component responsible for loading, firing, and ejecting cartridges. The action requires intricate engineering and precise fitting to ensure flawless operation and reliability. In a Holland firearm, the action is handcrafted from high-grade steel to guarantee durability and strength under repeated use. The process of crafting the action begins with cutting and forging the steel into rough shapes. These components are then hand-fitted by skilled gunmakers who ensure that every moving part works in perfect harmony. The locking mechanism, triggers, and ejectors must all operate with precision, and each element is finely tuned to ensure reliability in the field. Particular attention is given to the triggers, which must provide a clean, crisp break when fired. In a gun, the triggers are a masterpiece of engineering, delivering consistent performance shot after shot. After assembly, each action is tested rigorously to confirm its reliability and flawless operation. This process guarantees that every firearm functions perfectly for generations to come. Firearms are not only engineering marvels, but also works of art. The engraving process transforms a finely crafted gun into a unique, personalized masterpiece. The engravers at Holland and Holland are artists in their own right, using traditional hand tools to create intricate patterns and designs on the steel surfaces of the gun's action, barrel, and trigger guard. Each engraving is done by hand, following a design that may range from traditional scroll work to detailed game scenes. The engraver's skill is showcased in the level of detail and depth they are able to achieve, transforming steel into an ornate canvas. Many of the designs have been passed down through generations of craftsmen, preserving the artistry of classic British gunmaking while allowing for the personalization of each firearm. The final stage of gunmaking is the finishing process, where every part of the gun is polished, coated, and assembled to perfection. The metal parts are blued or case-hardened to provide protection against rust and corrosion, while the stock is given its final coat of oil to ensure its longevity and enhance the beauty of the wood. The finishing process also involves careful assembly and final testing of the firearm. Every component is inspected and polished to ensure that the gun not only functions perfectly, but also looks stunning. The fit between the metal and wood is checked. The engraving is inspected for any imperfections, and the gun is assembled with the utmost care. The result is a gun that embodies the best of both art and engineering. Every firearm is a unique creation, a testament to the skill and dedication of the craftsmen who produce them. With its flawless balance, precise action, and stunning appearance, a Holland and Holland gun is not merely a tool for shooting. It is a piece of history, a legacy of craftsmanship that spans nearly 2 centuries. The manufacturing process begins with local die-cast plants, where solid aluminum shells are created by melting the aluminum at over 1,000 degrees Fahrenheit and molding it into marker components. These shells are then prepared for assembly through additional processes like internal component fitting and painting. Many of Tippmann's more complex and critical parts are manufactured in-house at their CNC facility. After all components, both in-house and outsourced, are ready, the final assembly of the markers takes place on Tippmann's production floor. Tippmann emphasizes quality and reliability, conducting live fire testing and life cycle assessments to ensure each marker meets their rigorous standards. Each gun must withstand 100,000 shots to be considered Tippmann grade. Tippmann paintball markers are renowned for their durability and reliability, traits that have been their hallmark since the company was founded in 1986 in Fort Wayne, Indiana. Known for producing the Chevy truck of paintball, Tippmann markers are designed to be tough, affordable, and suitable for all levels of play. From their classic SMG-60 to modern models like the 98 Custom and A5, Tippmann continues to push the boundaries of performance while maintaining their reputation for building some of the most dependable paintball markers on the market. The manufacturing process of pistols at Trabzon Sila Sanayi AS Tisas involves several intricate stages, starting from design and continuing through production, quality control, and final testing. Established in 1993, Tisas operates out of a modern facility in Trabzon, Turkey, and is recognized for its high-quality firearm production, particularly its pistols. The process begins in the design phase, where technical teams develop detailed drawings using advanced 3D modeling software. These designs serve as the foundation for the machining process. Once the designs are complete, raw materials, including various types of steel, are processed with CNC machining technology to produce the required mechanical parts. The company has integrated a flexible manufacturing system, allowing it to produce custom parts alongside full pistols. Each part is rigorously tested throughout production to ensure it meets the exact design specifications. After machining, parts undergo a series of treatments. Tissot's in-house heat treatment facilities, featuring 2 separate furnaces, enable it to work with both standard and stainless steel. Following heat treatment, parts are subjected to processes such as chrome plating, painting, and marking. All components are then coated, stored, and prepared for final assembly based on customer specifications. The manufacturing process of pistols at Trabzon Sila Sanayi AS TISAs involves several intricate stages, starting from design and continuing through production, quality control, and final testing. Established in 1993, TISAs operates out of a modern facility in Trabzon, Turkey, and is recognized for its high-quality firearm production, particularly its pistols. Quality control is an essential part of the manufacturing process. Assembled pistols undergo a variety of inspections, including visual checks for surface defects and functional tests. These tests ensure that critical components like the barrel, slide, and frame operate smoothly and that safety mechanisms perform flawlessly. The 7.62 mmkbk AK is a widely recognized variant of the AK family of rifles, specifically designed to use 7.62 by 39 mm cartridges. With a weight of approximately 3.1 kilograms, an overall length of 880 millimeters, and a barrel length of 415 millimeters, the rifle is compact yet powerful. It features a rotating bolt mechanism, which enhances the reliability of the rifle, and it can be configured for either semi-automatic or full automatic firing modes. The standard magazine holds 30 rounds, and the rifle has a muzzle velocity of about 715 meters per second. Below is a detailed overview of the manufacturing process that goes into producing this iconic weapon. Machining process of the 7.62 mmkbk AK rifle. Machining is a crucial step in the manufacturing process of the 7.62 mmkbk AK rifle, ensuring that each component meets strict dimensional and performance standards. This stage transforms the rough shapes produced during forging into finely crafted parts essential for the rifle's functionality and reliability. The machining process often utilizes computer numerical control (CNC) technology. CNC machines allow for precise control over the cutting tools that shape the metal parts. Programs are created to dictate the exact movements of the machine, allowing for intricate operations that manual machining cannot achieve. This precision is vital for components such as the bolt carrier, receiver, and barrel, where tolerances must be tightly controlled. Milling. This operation removes material from the surface of the component to achieve the desired thickness and features. For instance, the receiver may undergo milling to create slots for the trigger mechanism and magazine well. The CNC milling machine uses rotating cutters to carve out these features with high accuracy. In turning, the component is rotated against a stationary cutting tool. This method is commonly used for parts like the barrel. The interior chamber of the barrel is turned to create the necessary diameter, and threads are cut for attachments, ensuring a secure fit. Its design simplicity, compact dimensions, and ease of mass production have contributed to its widespread use across various military forces around the globe. A variant of the AK, the AKS, features a folding stock, making it even more adaptable for different operational environments, as evidenced by its use by a training officer of the Afghan National Police. The AK-47 was originally engineered for Soviet soldiers, particularly those stationed in Arctic conditions, who needed a reliable firearm that could be operated with heavy winter gloves. This led to the incorporation of a large gas piston system and wide tolerances between moving parts, enabling the rifle to function effectively in adverse conditions. One of the rifle's most notable traits is its ability to tolerate significant amounts of dirt and debris, even when production standards are not rigorously upheld. While this rugged design may compromise accuracy and increase shot dispersion, the Alaska 47 is primarily intended for engagements at ranges under 400 meters. At this distance, A few centimeters of deviation is unlikely to hinder hit probability, especially during sustained automatic fire. The Soviet infantry doctrine of the time emphasized the importance of assault rifles in close-range combat, reserving long-range precision duties for medium machine guns like the RPK, general-purpose machine guns like the PK, and sniper rifles like the SVD Dragunov. The lifespan of the Alaska 47 can vary widely, from 20 to 40 years, depending on environmental factors and the frequency of maintenance, making it a durable choice for military applications. Key structural features. The structural design of the Alaska 47 features several crucial components that enhance its functionality. Gas operation and loading mechanism. The rifle employs a gas-operated mechanism that uses a gas port located about 1/3 of the way down the barrel. This system is effective for cycling the action and ejecting spent cartridges. Rifling. The bore of the barrel is rifled with 4 grooves, featuring a twist rate of 235 millimeters, which helps stabilize the bullet in flight, enhancing accuracy. Sights. The front sight is positioned at the front of the receiver and is adjustable via a slider. It is made as a single piece with the rear sight base, which has a V-shaped notch for aiming. This design aids in quick target acquisition. Front sight post. This post includes protective walls and can be adjusted vertically to fine-tune the range when zeroing the rifle. It also features a base with a horizontal pin for windage adjustments. Piston system. The rifle has a monoblock piston that connects directly to the bolt carrier, contributing to its robust design. Hammer mechanism. A rotating hammer is equipped with a sear to facilitate single-shot firing. Extractors. The rotating bolt extractor is pivotal in removing spent casings from the chamber. As the bolt retracts, the extractor evenly distributes the pulling force around the rim of the casing, reducing the likelihood of jams. The Alaska 47 boasts impressive performance metrics, making it a formidable weapon in various combat scenarios. Theoretical rate of fire. The rifle has a theoretical rate of fire of approximately 600 rounds per minute. Combat rate of fire. In practical situations, it can achieve around 40 rounds per minute for semi-automatic fire and up to 100 rounds per minute in full automatic mode, while the Alaska 47 does not feature a 3-round burst mode like the M16 or AR-15. Its slower rate of fire allows skilled shooters to effectively control their shots. By training themselves to pull the trigger in quick succession, marksmen can fire 2 rounds consecutively with high accuracy. This technique gained prominence among Vietnamese People's Army snipers during the Vietnam War and remains popular among shooters today, regardless of the rifle's specifications. An experienced shooter can often achieve 2 impacts on target at 100 meters with only 10 to 15 centimeters of dispersion. Effective range, semi-automatic mode. The effective range is up to 800 meters, making it suitable for various engagements. Automatic mode, 400 meters, effective at 0 degrees or a slightly positive angle. 200 meters, effective with a negative angle not exceeding 15 degrees. Maximum grouping, achieved at 300 meters with a 0-degree angle. In practical terms, the Alaska 47 is typically zeroed at 300 meters, which corresponds to the point-blank range for many combat scenarios.